Solving linear equations. Today we're going to get started with solving equations by practicing how to solve one-step equations. So our objective today is I can solve linear equations in one variable. Our goal is to get x by itself. So some unit vocabulary includes the additive inverse. An additive inverse is what you add to a number to get a zero. So examples would include the additive inverse of a -5 is 5 because a -5 and a +5 equals 0. Or another way of saying it is a -5 plus 5 equals 0. Likewise, the additive inverse of a +5 is a -5 because if you have a +5 and you subtract 5, or if you have a +5 and a -5, again, you get 0. So, to recap, additive inverses make zero pairs, and this is going to be crucial when we're solving equations. We do the inverse or opposite operation to create a zero pair. The opposite of addition is subtraction, and the opposite of subtraction is addition. So wherever we see one operation, when we want to create a zero pair, we will do its opposite operation to create a zero. Solving equations using the additive inverse. So in this first problem, we have x plus 8 equals 13. Remember, our goal is always to get x by itself. So in other words, given this equation, we want the x to be the only thing on this side of the equal sign. Right now in this problem, the x is accompanied by a +8 or a +8. So in order to get x by itself, we need to create a zero pair with this +8 or +8. So what we're going to do is we're going to use the additive inverse to create a zero pair. So the additive inverse of a +8 is a -8, or the opposite of adding 8 to any number or variable would be subtracting 8. And we have to make sure that whatever we're doing to one side of the equation or the equal sign, we do the exact same thing to the other side. So if we're going to subtract 8 from this side, we need to subtract 8 from this side. A +8 and a -8, or a +8 minus 8, gives us a 0, leaving us with just x on the left-hand side of the equal sign. And then 13 minus 8 gives us a 5. So therefore, x equals 5. Our last step is to check our work to make sure we got the correct answer. So now we know that x isn't really an x, it's actually a 5. So when we go back to our original problem, instead of writing an x, we'll actually put our answer, which is 5. So we will write 5 plus 8 equals 13. Well, 5 plus 8 is 13, so our answer checks. Here's another example. Here we have 27 equals x minus 13. And again, our goal is to get x by itself. So looking at this problem, here's our x, and what is on the same side of the equal sign in this problem? A -13 or a -13. So again, we want to create a 0. We want this to go away. So to create a zero pair with a -13, we need to have a +13. Which would be the additive inverse. In other words, if we see a -13 or a -13, we have to do the opposite. We have to have a +13 or an addition of 13 in order to create a 0. And again, whatever we do to one side, we must do the same exact thing to the other side of the equal sign. When we do this, 27 plus 13 gives us 40. A -13 or a -13, and then when we add 13 or a +13, we create a 0, leaving us with just x on this side of the equation. So x equals 40. Last step is to check our work. Plug 40 into x for the original problem, and we will find that when you take 40 minus 13, you do get 27, so that checks. Try these on your own. Please pause this video now and give these problems a try. Let's see how you did. How'd you do? All right, let's move on. So now we're going to be talking about the multiplicative inverse. In other words, the reciprocal. The multiplicative inverse is the number you multiply another number by to get 1. In other words, when you multiply a number by its multiplicative inverse, you get 1. Here are some examples. The multiplicative inverse of 8 is 1 over 8, because if you multiply 8 by 1 over 8, you get 1. So this would be saying 8 times 1, which would give you 8 in the numerator, and then there's an invisible 1 underneath this whole number. So in the denominator, we'll get 1 times 8, which is 8, and any number over the exact same number gives you a 1. So 8 divided by 8 is 1. Same is true of a negative 4 over 5. Its multiplicative inverse would be a negative 5 over 4. Note that this is negative and so is this. The only thing that flips or changes is the fraction. This is true because a negative times a negative will produce a positive. 4 times a 5 will give us a 20 on the top or in the numerator. A 5 times a 4 gives us a 20 on the bottom or in the denominator. And a positive 20 over a positive 20 will give us a positive 1. We do the inverse or opposite operation to create a coefficient of 1. The opposite of multiplication is division. The opposite of division is multiplication. So here's an example. 3x equals 27. And again, our goal is to get x by itself. So right now what we need to do is we need to identify what is happening to our x. We see there's a 3 in front, which means there are 3 x's. But that also means the operation that is happening to the x is multiplication. In other words, the 3 is being multiplied by the x. So in order to get x by itself, we need to multiply the 3x by its multiplicative inverse, which would be 1 over 3. We do this so that we can convert the coefficient of 3 to a 1. Now, although this is the multiplicative inverse, this is not how we generally write or show our math when solving equations. Instead of multiplying by a 1 over 3, we'll just go ahead and divide by 3, because 3 times 1 gives us 3 in the numerator, and 3 times 1 in the numerator will also produce a 3. So the way that we will show our work is we'll just simply divide each side by 3. Because again, we're going to do the opposite operation. Here we have multiplication happening, so in order to create a coefficient of 1, we will do the opposite operation, and the opposite of multiplication is division. And whatever we do to one side, we must do to the other side. So 3 divided by 3 is going to cancel out, giving us a coefficient of 1, and 27 divided by 3 is going to give us 9. The next step is to check our work to make sure we did everything correctly. We'll now go ahead and plug 9 in for x, and again we have multiplication happening here, so it turns into 3 times 9, which does equal 27. That checks. Now let's look at a division problem. Here we have x over 5 equals 7. That x over 5 is actually saying that our x is being divided by 5. So in order to get our x by itself on the left-hand side of the equal sign, we need to turn this coefficient, which is actually 1 over 5, into a 1. And we will do that by using the multiplicative inverse, or the opposite operation we see. We see that x is being divided by 5, so the opposite of dividing by 5 would be multiplying by 5. And again, whatever we do to one side of our equation, we have to do the same thing to the other side. So we're going to multiply both sides by 5, or 5 over 1. This will give us a coefficient of 1. So when we multiply each side by 5, these will cancel out, giving us just a 1x. And remember, when we have a coefficient of 1, we don't need to write the 1. And then on the other side, we'll get 7 times 5. so x will equal 35. To check our work, 35 divided by 5, yep, that sure is 7, so here we have done the math correctly. Here's a couple problems for you to try. Go ahead and pause here and see what you come up with. How'd you do? Some of us may have struggled a little bit over here, but remember, we're going to use the multiplicative inverse. So the multiplicative inverse of a 2 over 3 would be to multiply both sides by 3 over 2. When we do that, these 3's will cancel, these 2's will cancel, giving us a coefficient of 1. And then we'll do 4 times 3 in the numerator to give us 12. There's an invisible 1 down here times 2, which leaves 2 in the denominator. Then 12 divided by 2 is 6. And then we could double check to make sure we did the math correctly by plugging 6 in for x. 2 times 6 is 12. 12 divided by 3 is 4. And that completes our notes on one-step equations.